AI. So this talk is for you if either maybe you're a data scientist, but your team actually needs infrastructure. Has that ever happened to anybody? It hasn't happened at my company, but this talk is kind of like what I wish every data scientist knew about DevOps. Or maybe you just want to know what your infrastructure team is doing behind the scenes. So that's what this talk is about, just enough DevOps for data scientists. First, a little bit about me. I'm Anya, my Twitter handle is here. I'm a senior member of technical staff. I'm on the SRE team at Salesforce, the site reliability engineering team. I support the Salesforce Einstein platform, so you might have heard about that a few times at this conference. So you can talk to any of us about the platform or what it's about. We are hiring, hint. I am also a co-organizer of the SF Big Analytics meetup. We have almost like 5,000 members. We're growing really fast, so that's a lot of fun too. I've done some work around Spark tuning. There's a cheat sheet that you can click on. I'll post my slides later. And I've done some talks around that. So come talk to me about those things if you like. So what I'm going to talk about today, first, what is DevOps, just so that we're all on the same page. Tell you about Salesforce Einstein and how we're scaling. I'm going to tell you about our goal from the infrastructure perspective. And I've kind of distilled down some best practices that I've found as we build a scalable machine learning platform. So I'll give you those top 10 tips, and then think about what's next. Okay, so what is DevOps? I consider DevOps to be kind of that intersection between software development, infrastructure, build and release, and also some networks and security. So that's kind of my working definition of DevOps. So we're kind of at that sweet spot, right in the middle. Maybe you think of data scientists as way outside. I hope not. Maybe some people do. So when you go to, as a data scientist, you think, oh, I want to run my machine learning job. I've got this awesome library. I've got Optimus Prime, and I want to run it on Spark ML. Okay, so hey, infra, can you just give me some clusters? I need a Spark cluster. Oh, and I need some microservices. Okay, so we need to deploy a cluster. Maybe we've got a cluster running. Let's deploy those microservices in some containers. So maybe this brings you a little bit closer to your DevOps team, I hope. And so we, at Salesforce, we're scaling like crazy, as you probably know. So I need to think about all these requests from my data science team at the level that Salesforce is scaling. And Salesforce Einstein is no exception. They're serving up 475 million predictions every day. So we're definitely needing to build and build and build. But what is my goal from the infrastructure perspective? As I increase the number of predictions, that's my blue dot, I want to scale the number of predictions as much as I can. But my infrastructure costs should not scale at the same way, right? So I want to keep those in check. So this is my goal, and I hope that we can all kind of agree on this unified goal. So if there's any people in the room who still have their data science hats on, go ahead and take those off. Because I think in data science school, they teach you if you build your model and if you keep working at it, keep training, then eventually your model is going to work consistently. But in the infrastructure world, I'm running thousands of servers, and I know that some of them are going to fail. Even if I do everything right, they're going to fail, right? So I need to plan for failure. So that's kind of this tip number one, plan for failure. I know failure is going to happen. I actually need a way to dig in and troubleshoot quickly. So I need a dashboard. And the dashboard in the car is awesome, and it's been that way for a long time because it's simple. It's got my key performance indicators. It's got my speed, amount of gas in my tank. That way, if there's a problem, I've got a simple place to look, and I can dig in later and dig in for more details. So what does the dashboard look like from an infrastructure side? I stole this dashboard from Joost Bomans, who is on the Salesforce data management platform. So this is a very simple dashboard. It may not look simple at first, but I'll go through it. We need a dashboard like this to give me information about every machine in my system. So here he's got a service this is a microservice that's running. And over this 2-day window, I can see the line that's fluctuating up and down. Let me point to it. See if this will work. You can see that, yeah? Okay, so my line that's fluctuating is going to be my number of requests coming in. And then the line way down at the bottom is the number of errors that are coming in, right? So my error rates. So that's the first thing I want to see on my dashboard, like the speed on my car. I need to know how many requests are coming in and how many errors are coming in. Secondarily, I want to know the response times. So I'm building a microservice. I want to know what type of latency are my users experiencing, and I don't want to know the average latency, because that's like saying I don't really care about half my users, right? I want to know the worst latency. I want to know the highest response times that people are seeing with my microservice. So he's got that plotted. The yellow line is the upper 99th percentile of response times. So this is kind of a key performance indicator for my microservice, for something really handy. The other thing he's got plotted in the vertical lines are events. So let's say there's been a deployment. I can see that event, and I can see, oh, this is how the response times changed after that particular deploy. Maybe my data engineer wrote some code and it wasn't so great. So I can see how that's related. So the point here is that you need a dashboard like this that shows me my key performance indicators. I want to deploy that dashboard, and I want to collect those metrics for every single machine. But I don't want to stop there. Like when you're driving your car, you see, oh, the engine light came on. So I might see that on my dashboard, but then I need to dig in more. I need to open the hood. There's a chip in every car that you can take to your mechanic, and you can find out tons of metrics about your car. And the same thing applies here. We want to collect every single metric possible. StatsD is a great open source tool that lets you collect metrics. So I would recommend trying that one. So the first step there is just to plan for failure and know what you're going to do to troubleshoot. The second one, probably everybody's familiar with this. Maybe data scientists aren't, so I'll just go through this quickly. Blue-green deployments. So I've got my users, and they're talking to my service that's running on the current machine, which is blue. Let's say, oh no, this machine is having problems. It needs to go under maintenance. I need to spin up a new machine, my new green machine. All new connections should go to the green machine, right? And the old connections will just continue connecting to the blue machine until they drain out. So this is the concept of blue-green deployments. Okay, so that's pretty simple. The next one, assume people make mistakes. And I mean people, I mean me and my team and you and your team, we all are going to make mistakes. I kind of group the mistakes into two categories, technical debt and like overusing resources. Okay, so technical debt. I think that every manual change that I make is some technical debt that I have to go and fix later. Other things, like if I'm building my dashboard, let's say I made duplicate metrics. I need to go ahead and clean that up. So we actually plan that into our system. So we have quarterly debt days. So the SRE team goes into a room and we close the door and we just handle our debt. We don't take any new requests, right? So we handle all of those manual changes and add those to some automated tool in some way. So handle your technical debt. The other one, scaling down resources. So this is kind of a no-brainer. Spin down your unused instances. If you're using AWS, Janitor Monkey is a great tool for that. Netflix came out with this whole simian army, but Janitor Monkey is a great tool. It says, hey, oh, I've noticed that this machine is idle. Let me send an email to this particular data scientist who's responsible for that machine. And if that data scientist sends an email back to Janitor Monkey, basically extending the lease on that machine, okay, that machine can stay up. Otherwise, that machine's going to be spun down. So spin down unused resources, kind of a no-brainer. And that really helps you understand the cost per job when you're thinking about cost to serve in whatever service that you're providing. It really helps you understand that cost per job. Okay, so assume that everybody is going to make mistakes. And then the other kind of leads me to my next point. All of the changes should be auditable. So mistakes or changes that we made on purpose, they should be auditable. Everything from network connectivity to infrastructure to everything. So here's an example. Q, who's an SRE on my team, he built this tool. It's not open source yet, but I just recommend to build similar tools to what I'm going to tell you. So this tool is called Schaper. It compares schemas. So this is one example of making sure that every change is auditable. So let's say I've got a database on the East Coast and I've got a replica on the West Coast. I want to make sure that the schemas in both replicas are the same. So let's look at my schema. I've got a create table statement. So my schema looks pretty similar between East Coast and West Coast. I've got my list of conferences, the columns in my schema, the name of the conference, the city, the date where the early bird discount applies, very important. So it looks like my schemas are the same, they're identical. And so Schaper will actually continuously run an audit on my schemas. Schaper will generate a report if there's any difference. So if there's a difference, Boolean, and what the difference is. And that report can actually send an email to me or to a listserv and say, hey, there's a change. And then we can talk about the actions that Schaper will initiate then. Let's see what happens. So, oh no, there's been a change. On the East Coast, somebody's added a discount code. I need to know this. This is important. So there's been a change. Schaper will say, oh, there's been a change, and it will send an email. Schaper can also enforce that the schemas should remain the same. So Schaper can actually say, nope, you can't add a column to that particular schema in that database because it has to be the same. So the actions that Schaper will take are configurable to the particular schema. And Q actually wrote Schaper to be generalizable. So Schaper can be used to compare schemas for Elasticsearch or Cassandra or MongoDB. So it's generalizable across databases. And you might be thinking, wait, MongoDB is schemaless. So Schaper actually thinks about indices and compares the indices across the MongoDB database examples. The other thing about Schaper, it's modular, so it's plug and play. So this is just an example of one of the tools that we've built to make sure that all changes are auditable. And I would just recommend that you think about these types of tools in your systems too. So we talked about a lot of changes. There's all these configurations that happen. So the next tip is to use a configuration management tool. An example might be Console from HashiCorp. So where am I getting all these configurations? Well, let's say data scientist and data engineer says, hey, infrastructure, I need you to do something. I need you to, I want to run a new Spark job, and I want you to spin up a new microservice for me. No big deal, right? Well, I've got maybe 20 parameters I need to configure for network connectivity. I've got maybe 50 parameters to configure for user access, which I probably should use Chef or Puppet for, right? I want to deploy a cluster, so maybe that's 20 more non-default parameters. So all these parameters, they really add up. Let's say I want to build this in 3 regions, and I want to collect 20 metrics per host. That really adds up, right? I've got 6,000 metrics. It's just 6,000 different configurations that I need to set up. I need a tool to do this, right? So use a configuration management tool. And to help you with that, pick a naming convention and stick with it. So for example, a naming convention might be service, environment, region, hostname, and metric. It's just a naming convention. But it's so helpful if you want to create some templates for automation. If you want to do service discovery, create your dashboard so I can filter my dashboards. This is everything related to prod. This is everything related to dev. Really helpful if you actually want to query your logs. So that naming convention comes up there too. And then for cost analysis, if I want to know how much is the scheduler costing me, the naming convention is helpful there. So I've got my server that I've been asked to spin up. I need to think about the users and the permissions that are going to access that service. So if you are using AWS, this is kind of a paradigm that you can take home and use. AWS thinks about permissions in terms of IAM roles, so identity and access management. It's basically the concepts of authentication and authorization. So I've got my user. My user has an IAM role, and that allows the user to access the service. Okay, great. Maybe the service is the scheduler. And this scheduler is going to create a Spark job that's going to run on, for example, an EMR cluster. Well, that scheduler has its own IAM role. And the Spark job has its own IAM role. And the EMR cluster has its own IAM role. I hope you're getting the point that we need permissions specifically at every level, at every step. And these IAM roles then determine what that user or service or job, what that job can write to or what can read to. So I can read from the input bucket and I can write to the output bucket. So the point here is apply permissions at every level. Okay, so I've got my permissions. I want to run my job. Okay, I need to now understand resource allocation. And this comes up so frequently. So I've got my Spark job and I want to run my Spark executor. So on the right here, I've got a diagram that I stole from 2 folks at Duke University, which I really like. This diagram shows the Spark executor and how the memory is handled in the unified memory pool. So that's awesome for understanding the memory allocation within the Spark executor. But what I want to talk about actually is outside the Spark executor. So let's just look at the blue box, the container. Let's simplify things. This is just my Spark container. It's 8 gigs. It needs to run on a particular node. So my question as a data scientist, I want my job to run. Can my container launch on my cluster? OK, let's see. So my cluster is 3 nodes. And OK, great. Each node is 8 gigs. Awesome. Oh no, I see that 4 gigs are already used on each node of the cluster. So can my container launch? What do you think? No. Right, the answer is no. So I might think my container could launch if I'm monitoring my cluster at the total amount of resources, at the level of the total amount of resources. So I've got 3 nodes, I've got 4 gigs per node. Hey, I've got 12 gigs of RAM available. My container should launch, right? Well, no, the answer is no. There's no individual host that has 8 gigs available. So my container is going to be pending until resources become available. So this is just very helpful in understanding, like, as a data scientist, are your jobs going to launch? OK. And then this is another tip. Sorry, there's like a hodgepodge laundry list of tips. This one's another one that I really like. So the point is to monitor multiple viewpoints. So here I've got a camera. Most of the cameras just have a single lens. Well, this camera has 16 different lenses. And with this camera, I can use different focal points to understand my environment, right? So that's how we should think about our environments as an infrastructure team. Okay. So this is an example of a tool that we've built to monitor multiple viewpoints. Vaibhav is another member of the SRE team, and he built this tool. So it's a connectivity diagram. So every circle represents a host, and every arrow connecting them represents some connectivity. So if I have an arrow from one host to another, that means that connectivity is allowed on that particular port from that host to another port. So it's really helpful. And you can see I've got 3 clusters there: my dev environment, my staging environment, and my prod environment. So it's great that I don't have any connectivity from prod to dev, because if I did, that would be a red flag. I need to look at that. And I also see there's some individual nodes kind of flying off by themselves. Maybe those are some nodes that somebody spun up as a test. I probably should spin those down if they're not being used anymore. So this is one way that we look at network connectivity. And if I click on a single node, I can say, this is what connectivity is allowed from this particular node. Or I could color the blue circles as the hosts and the orange circles as the load balancers. Or as another viewpoint, I could limit. I could search based on all of the nodes that are used for the scheduler service. So the point here is to monitor multiple viewpoints. OK, so what have we said today? Plan for failure, use blue-green deployments, assume that people are going to make mistakes, and have a plan to fix those. All your changes should be auditable. Use a configuration management tool. Pick a naming convention and stick to it, please. And I should say you don't have to actually stick with your name. You can create a variable and pass that in. But just stick with the convention. Apply permissions at the user level, the service level, and the job level. Understand resource allocation, and monitor multiple viewpoints. And I hope that I've convinced you to deploy your infrastructure as code. That's kind of the summation of all of the items that I've talked about today. So did we just automate ourselves out of a job? Well, no, I don't think so. I mean, now we have time to take on new projects and to grow, and at Salesforce, that's always going to happen. So if you want some next steps, you want to dig in deeper, I would check out a couple of books. There's a great book from Google, SRE, How Google Runs Production Systems. If you're curious about Salesforce stuff, check out James Ward. He gave a talk here. He's our engineering and open source ambassador. And then also Joost Bowmans, I showed his dashboard. I think he's given a lot of great talks on the goal that I shared. You want to scale out your key performance indicator, but you don't want to scale your infrastructure costs. So Joost has some great talks there. And if you're curious about Spark operations, the book High Performance Spark has some really, really good, useful tips there. There's a whole chapter on joins. And then these are the talks that are given at this conference for Salesforce Einstein. So check those out. If you have questions about those talks, you can ask me too. And I thank you for your attention. I'd be happy to take any questions, and I'll be around. Thanks.
Thanks very much. Any questions? shout it out. About the that example, point number 4 about keeping your code the same on East Coast and West Coast.
Oh, right.
Isn't that just source code control? I mean, what was the special thing about that I didn't get?
Sure. So I think the point there is that let's say there was a change that was made outside of your standard deployment system. Let's say you're trying to replicate your databases, but it didn't actually work. Or you might actually want the data in Europe to actually be different than the data in the US. Maybe companies in Europe need to keep their data in Europe. So it's a schema comparison tool that basically says, oh, these schemas are different, or oh, they're the same. So yeah, it's kind of like after the fact. Yes, your source code, your build and release cycle should usually have consistent schemas. Maybe you didn't all the time. Yeah.
Hi, Anya. Great talk.
Thank you.
So, question regarding some of the things you mentioned in terms of sort of figuring out which containers are available and managing all permissions. Do you do this at Salesforce manually, or do you have some sort of single system?
We never do it manually.
Okay.
So are you asking how we manage our permissions?
So I guess like you mentioned a whole bunch of things. So permissions, resource allocation. So do you have one single system you use to manage all that, or is it sort of individual DevOps?
Well, in my opinion, a tool should do one thing and do it well.
Okay.
So I don't have one tool that manages configurations and users. You could use Chef or Puppet. What I would recommend is to make sure that your systems are automated, and if you have the same naming system, naming schema, or naming convention for everything in your system, then all of your tools can work together.
Cool.
Yeah.
Any further questions for Anya? No? Well, thank you so much.
Thanks.